Hello, my dear students and the rest of the learners. Welcome to part 2 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this tutorial, we are going to be learning about the format or the structure for a C program, and we are also going to write our first program in C. My name is Meme JM, or you can simply call me Emily Swap. Whenever you are saving your source code in C, make sure you save it with .c extension. For example, welcome.c. However, my dear students and the rest of the learners, as I said in part 1 of this series, we said that once you give your C a name and you have chosen C compiler, the name of your file will be automatically added .c extension. And therefore, you don't need to type .c extension as long as you have used your Falcon C++ well, and during the time of creating your file, you have chosen compiler as C, because the name will be added .c extension automatically. In addition, you should make sure that your source code adheres to the structure or format for a C program. In other words, my dear students and the rest of the learners, every programming language has a set of rules, or what we call the grammatical rules, that govern how you write instructions using that language. By the look of a code written by a programmer, one can be able to tell which programming language has been used. Why? Because of the structure or the format that those set of instructions have been written with. And therefore, when you are writing your program in C, there's a specific structure that your code is supposed to adhere to. So other than having the name of your file, having .c extension, there's also certain rules that you need to adhere to. There's a certain structure or a certain format that your source code must adhere to, and that format is not negotiable. The format remains. And that's what we are going to be learning in this presentation. So a program structure is simply the overall form of a program with particular emphasis on the individual components of the program and the interrelationships between these components. Therefore, a program format is the accepted arrangement of the various components within the editor while abiding to the rules governing a programming language, thus forming a valid source code that can be executed to solve the problem at hand. Different programming languages have different formats, and therefore it is that format that must be adhered to for the compiler or translator to be able to convert your program into what we call object program. C is generally case-sensitive language, and therefore all the source code should be written in lowercase. In other words, my dear students and the rest of the learners, make it a habit to be writing your set of instructions in C programming language using small letters. This is a rule. C is case sensitive. So if you write two names, one will begin with a capital letter and the other one with small letter, even if those names are the same, they will be having a different meaning to the compiler. And therefore, you are saying that as you begin writing your programs in C, make it a habit to be writing all your set of instructions in lowercase or what we call small letters. So the general format for C programming language source code is as follows. One, it's always good to make your program readable. Making your program readable is a method that you use to be able to inform the reader of your source code what each part of your program is doing. And for that reason, it's always good to include comments within your code. And how do you put a comment? You place a comment using the symbols, like you can see here, where you have the / followed by the asterisk. And then you write your comments inside there where I've written the comments, and then you have the asterisk and then /. So that's one way of writing instructions in your program. And what I'm calling instructions are simply the comments. For example, tell somebody what that part of the source code is doing. For example, it can read section for adding numbers. That's just a comment. Comments are statements that are not executed by the compiler. So once you have placed your comments within the pair of symbols, as I've done, the compiler will ignore the comment. So these statements inside here can be in any language. Then after the comment, we have this statement here, which we are going to discuss. This is called #include, or you write it as #include. You use the less than symbol, as I've done, then stdio.h. So this is syntax that must adhere to. We have the hash symbol, then we have the ones include. We have the less than sign, then stdio.h, and we have greater than sign. We are going to see what this simply is all about. Then next, we have this statement. It is int, main, then pair of parentheses. These type of brackets, we call them parentheses. And then we have the one inside there, void. So int, main, opening parentheses, void, closing parentheses. And then we normally have what we call brace. This brace is facing your right-hand side. Then you write your set of statements here. This is where you write your set of instructions. This is where you write the statements that you like your processor to perform. And you can see they are terminated with a semicolon. And then we have what we call a return. So we have return 0 and a semicolon, and then we have this brace. So generally, my dear students and the rest of the learners, most of your C programs will adhere to that structure. Comments, #include stdio.h, int main. Then we have the opening brace. We have your set of statements there, each terminated with a semicolon. Then we have return 0, semicolon, and then we have the closing brace. So where most of the difference comes in is the type of statements that you include at this point. So that's what we call the general structure. Let's now look at each of these parts and see or know what each of them does. So the following is an explanation of the basic parts of a C program structure. First is adding your comments. So you add your comment between these symbols. So my dear students and the rest of the learners, note this. We have this pair of symbols here. So whenever you wanted to add a comment in your program, it's always going to have comments at each and every part because they make your program more readable and easy for most people to understand. It's always good to enclose your comment within that pair of symbols. So you write this symbol, That way, you write your comment and then you remember to close it with that. So any text that is enclosed in between here, between these symbols, is not executed by the compiler. For example, you can have a comment, or there's also another way of doing the comment. But before we come to that, my dear students and the rest of the learners, it's good to note that this is a method for adding comments within your source code. This method of commenting is used when your comment occupies more than one line. So if you have statements that occupy more than one line, that is the best place for you to put this kind of comment or this kind of symbol, or to make use of this kind of a symbol. For example, if I want to make this part to be a comment, I just need to enclose those statements and those symbols. So if this is a statement in my program, or these are comments in my program, these two lines will be treated as a comment. So the content inside here will be ignored by the processor during compilation. And therefore, if you want to add a comment that only occupies a single line, you use a different symbol. So which symbol do you use? We use this symbol here. This symbol is a symbol that we use when you want to add comments within your source code that occupy only a single line. Note, you can add comments in your program either using this pair of symbols, especially if your comment spans for more than one line, even though you can also use the same for a single line as I've done, or you can make use of this symbol if your comment will only occupy a specific single line. A specific single line. And therefore, those are the two ways of adding comments in your source code. You can either use the /* and you close with a similar pair at the end for a comment that spans for more than one line, or you can make use of double / symbol when you want to add a comment within a single line. The next part is #include str.h. This is a compiler directive to the C processor. It tells the C processor to include the contents of the standard input-output header file, stdio. Standard input-output header file. My dear students and the rest of the learners, note stdio.h. This is simply like an acronym, though it is a name for the file, but it stands for standard. Standard, that is std, standard input-output header file. It is a compiler directive to the C processor, telling it to include the contents of the standard input-output header file in the program. Simply, it is telling the compiler, go and read the contents of this file that has been saved as a header file. Bring that content into the current program. Make that code there to be part and a parcel of the code that the programmer is about to write. This processor directive is included in each program. that makes use of input-output library functions such as which ones? Such as scanf, gets, and printf that we are going to learn later. However, my dear students and the rest of the learners, kindly note that if your program is going to make use of any input or output statement, for example, getting any data from the user through the keyboard or displaying any data on the screen during processing or after processing for your program, you must include this statement in your source code. So this statement must be included in your source code. If your program is going to be making use of the monitor and the keyboard, which of course will happen, you cannot write a program without making use of your monitor to display, for interaction, to see what is happening. So always include stdio.h because you are telling the processor to go and read the contents, the functions for performing various activities that have been recorded in the file called standard input-output header file. So you must always include that if you are going to make use of the monitor and the keyboard in your program, which of course will happen. So if you will not read any value, either from file or from keyboard, and you will not display any information on the screen or write anything in a file, you can exclude this statement from your source code. But it is a good practice for you to always include that statement in your source code. Therefore, this header must be included in the source code before starting to make use of such functions. Any line beginning with hash are processed by the preprocessor before the program is compiled. In other words, any statement that you begin with hash within your program, it simply tells the processor to go and read that file, process it, and make use of the content in the program. The next part of a C program is int main. Int main. Then option 1, void. Now, what does this line do? This line shows the start of the main part or the main function of the program, also called the body of the program. So there is no C program that you are going to write without including this function, which we call main. We are going to learn more about the functions later in the series, in the subsequent videos, this series, about the functions. But for now, note that any program that you write in C will have this part of your code or this function, which we are calling main. So int main, then void. The parentheses after main indicate that main is a program building block called a function. So any C program that you write as the main function, this is the function which controls the flow of execution of instructions within your program. The optional keyword int to the left of main indicates that main returns an integer or a whole number value. My dear students and the rest of the learners, for now, don't mind about what that word int is all about in relation to the main. Just know that anytime you are writing your program in C, included in your code, we are going to discuss more about what int is all about later on in the series, where we are going to be learning about what we call the functions or subprograms. If the main function is not preceded by int, it will still be there by default. Therefore, if you do not want the main to return any value, you can replace it with a keyword void. The optional keyword void and closed in the parentheses indicates that the main function does not receive any information. Just as I have said, for now, you can avoid including the word void in the parentheses and have it just as a pair of parentheses. Then the next part is the left brace and the right brace. Now, these must always go in pairs. Every left brace must have its right brace. What do those do? The left brace indicates the beginning of the body of every function, while the corresponding right brace indicates the end of the function's body. In fact, once you have written int main, then the next thing you have to include below it, just as you have seen the structure, is the left brace. And when you are coming towards the end of that main body, or once you are coming, as you come towards the end of the program, you have to include the right brace. This pair of braces and the portion of the program between them is called a block. Then we have return 0. Now, this statement indicates that the program execution has terminated successfully, and thus the program control should be taken back to the operating system. In other words, if the compiler is able to go through all the other statements accurately, that's the time when it will be able to reach this statement, which is normally found towards the end of the program. It simply tells the processor or the compiler that the program execution has terminated successfully, and therefore the program control can be taken back to the operating system. The keyword return is one of the several means to exit a function. This line can be completely left out if the return value for main was void. However, just as I have said, in relation to int, that is the return type, is a good practice to include it in your program, regardless of whether your main will return any value or not. It's a good programming practice in C to include it. After all, it will cost you nothing. It can also be included without a zero, for example, return, then a semicolon. So the following is an example of a C program. This program prompts a user for his or her surname and current age. It then welcomes him or her to C programming and informs him or her the number of years that he or she will be 10 years from today. My dear students and the rest of the learners, if there's something you not understand here, don't worry much. I will be explaining each and every part of this program later on in the subsequent presentations, but for the sake of giving you a proud chance to be able to interact with a real C program and be able to learn the structure, that is why I'm bringing to you and presenting to you this program in advance. So the following is an example of a C program. So first of all, we have the comment. So what does this comment do? It welcomes, or this program welcomes one to C programming and displays his or her age after 10 years. As I have said, it's always good programming practice to have comments within your program. As you can see, my comments are spanning 2 lines. Welcomes one to C programming and, as the first line, displays his or her age after 10 years. That's the second line. And therefore, that's why I'm enclosing that statement within those pairs of symbols for comment. Then we have #include stdio.h, which you have said is key, because if your program is going to be making use of the monitor or the keyboard, then it is important for the processor to know how to handle those devices. And the explanations for how that can be done are found inside the file that we call the standard input-output header file. So this is our preprocessor directive for stdio.h. Next is our main function. This main part, the main function, as you can see, must always be accompanied by this brace. Then from there, you can make declarations. This simply means that you can tell your processor to set some memory location aside to be used on certain values. So if your program is going to require you to enter some data into it to be stored for future use, then you have to inform the compiler to set certain memory locations aside for that use. That's what we call declarations. If your program will not require any data to be stored in advance, you don't need to declare. If you don't need to store any data in memory during processing. But if you are going to prompt the user to enter any data, it's always good to request the compiler to set memory location aside to hold those values. And that's what we are calling declarations. So here, I am setting a memory location aside called years. I'm giving my memory location a name. The name is years. It is to store data, which is a whole number, that is of type integer, and that value which is going to be stored there will not be changing. That's what const means here. So const int years equals to 10. So what this statement is simply doing, it is picking value 10 and assigning it or locating it or storing it in a memory location called years, which is supposed to hold data of type integer, and that value 10 should not be allowed to change. Next is I'm requesting the compiler to set another memory location assigned called your name, whose size should not exceed 20 characters, and that data is of type char. Next is I'm requesting my processor to set some more two memory locations assigned, one called future age and another one called age, both of them to store whole numbers. That's what int here means. Once you have set your memory location aside, the next is to enter your name and age through the keyboard. So this is a comment, and it's a single line comment. That's why it is being preceded by the 2/size. So what I'm about to do is I'm about to enter name and age. So this statement is telling the user to key in his or her name. So this statement will be displayed on the screen. That's why we have the word there, printf. Printf simply means print this or display this text on the screen. And the text is, what is your name? So this statement will be displayed on the screen. And the user will be required to enter or type a certain value. So the set of text that he or she will enter will be the name. So this name can be more than one name, like Julius Meme Lingera or Emily Swap. So once that text is keyed, it will be read, and then it will be stored in the memory location that we have called your name. From there, the next statement that will be displayed on the screen is, how old are you? That's the next statement to be displayed on the screen. That's why we have the word printf. It is telling the processor to display this text on the screen. Then the value will be read. How old are you? So the value that will be keyed in by the user will be read. That's what this statement means. It is telling the processor to read the value which is being keyed by the user and assign it or store it in the memory location called age. Then this statement is picking the value that has been stored in the memory location called years. Then it is added to the value in the memory location called age. And the results are being stored in the memory location called future age. So in other words, this statement is simply reading the value that is being entered by the user, the value that has been entered. For example, if the user keys in 10, that 10 will be kept in the memory location called age. Then the processor will pick that value and it to the value in the memory location called years, which is 10. So if, for example, the user enters 10, and what is in the memory location called years is 10, it will be 10 plus 10, which is 20, and that value 20 will be stored in the memory location called future age. From there, we want to display the age on the screen and the name. So the comment here is displaying your name and age on the screen. My dear students and the rest of the learners, you can see the beauty of adding comments in your program. You can see that even before I have displayed my statements, you are expectant, you know what we expect to see. So you expect to see a statement for displaying your name and the age on the screen. Here it is. So this statement is saying, pick what is in the memory location called name, your name, and display it on the screen, followed by the ones, Karibu Usome C programming. So this statement, or what will be displayed by this statement is the compiler will pick the content that is in the memory location called your name. Remember, in your name, you have keyed in your 3 names or your 2 names. So if, for example, you typed Julius Meme in your name, and that is what is in the memory location called your name, that is what will be displayed here as the first thing. So what will be displayed by this statement is Julius Meme, comma, Karibu Usome C programming. That's what we are going to see. Then the next statement is to display you will be, so the compiler will pick the content in the memory location called the future age. So if the content in the memory location called the future age is, for example, 20, this statement will be displayed as follows on the screen. You will be 20 years old, 10 years from today. Then that will mark the end of that program. The control will be taken back to the operating system, and that will be the end of the program. So my dear students and the rest of the learners, the purpose of this program is simply to show you the structure of a C program. 1, we have the comment. 2, we have the hash include preprocessor directive. Then we have the int main followed by this brace. After that, we now enter into the body of the program. And the body contains declarations and any other statements or instructions that would like to be carried out. All these are a part of the instructions. Then we have the statement return 0 and then this brace. So that's generally the structure of C program. Let us now code this program that we have discussed in Falcon C++ so that you can see how it will behave when executed. So what I'm just going to do is I'm just going to copy this program of mine because I've already explained. I'll just copy this program that I've already explained and I just put it in my IDE. And then we are going to see whether it will behave as I have already explained. So how do we proceed? So I'm going to open my Falcon. We already created our file in part 1 of the series. If, my dear students and the rest of the learners, you don't know how to start Falcon C++ and how to create your file ready for coding, kindly visit Swap ICT YouTube channel. Then go to part 1 of 29 of this series, where we learned about how to do that. And then go through it. Once you're done, you'll be brought to this screen. Or simply, what you need to do is launch Falcon in your computer. Once you launch it, create a project. And the name of my project is Welcome. Once you create your project, as explained in part 1 of the series, the next thing you do is to create a file within that project. And our file is called welcome.c, which we created in part 1 of the series. Now our file is ready. What we just need to do is to code our set of instructions here. This is the editor. This is the part where you do your typing from. So this is where you type your code. And therefore, let me enter my text here, my code. So you can either, if you have written your program or you have coded it using, for example, an editor, like word processor, you can just copy your program and paste it here in the IDE. Or you can just type your instructions directly. You can see my comments are in green. These are my comments. These are the comments. This is the comment we have discussed. So this is simply the program we have discussed. You can see the preposter directive is here. The main function is here, followed by that brace. We have our declarations here. We have our instructions all the way to here. We have our return 0 there, and we have our closing brace there. But always remember to indent your program correctly. And if you make a mistake, you undo. So let's indent our program. Indentation makes your program readable and more user-friendly. Always ensure that you indent your instructions nicely within your IDE so that your program becomes readable and more user-friendly. That also helps you even in the debugging. So that's our program. Now, once you have coded your program, remember to save it. So you click on File menu and you click on Save. So our program is ready. We have been able to code our program nicely. So my dear students and the rest of the learners, that is how we code our program. And with that, we have come to the end of part 2 of the series, in which you have learned the format or structure of a C program. You can now proceed to part 3 of 29, in which we are going to learn about how to compile and execute the program that we have already coded. Congratulations, therefore, for learning part 2 of 29 on the structure or format for a C program in Fundamentals of Structured Programming using C. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on Swap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emediswap@gmail.com. And in addition, if you'd like to join as a special member to enjoy more detailed self-teaching or self-training, you can also click on join the button that is next to Emediswap ICT, and then you just subscribe by paying some amount as will be required based on the level of interaction that you like to have with myself, especially if you want to learn more at your own personalized level. And with that, my dear students and the rest of the learners, God bless.